Hey everyone, welcome back to the channel. Picture stepping into a massive underground laboratory where enormous spinning arms whip multi-ton samples around at mind-boggling speeds to create forces thousands of times stronger than Earth's gravity, compressing decades or centuries of natural processes into hours or days of observation, so scientists can watch dams crumble under stress, pollutants seep through soil over geological timescales, or materials behave in extreme conditions that mimic deep Earth pressures or catastrophic events, all in a controlled setting that accelerates discovery like nothing else on the planet. Because today we're exploring the CHIEF1900 Hypergravity Centrifuge, the record-breaking centerpiece of China's groundbreaking centrifugal hypergravity and interdisciplinary experiment facility, or CHIEF for short, at Zhejiang University in Hangzhou that's just been completed and shipped for installation in late 2025, claiming the title of the world's most powerful scientific centrifuge with a staggering capacity of 1,900 G-tons to surpass its own predecessor, the CHIEF1900, and the previous global leader from the United States Army Corps of Engineers, opening new frontiers in geotechnical engineering, materials science, environmental studies, deep sea and deep earth resource exploration, and even insights into long-term geological or biological phenomena by literally compressing space and time through centrifugal force. The CHIEF project as a whole represents China's ambitious push into big science facilities, with construction approved in 2018 and starting in 2020 at a cost of around 2 billion yuan, or roughly $276 million, to build this national mega-science platform, buried 50 meters underground to minimize vibrations and ensure precision, housing three main centrifuges: the heavy-duty CHIEF 1900 as the flagship for massive loads, the high-speed CHIEF 1500 for finer accelerations, and the model CHIEF 1300 that came online in September 2025 as the interim record holder, along with 18 onboard experimental devices across 6 dedicated test chambers for interdisciplinary work spanning slope stability, high dam integrity, geotechnical earthquake simulation, deep ocean pressure, analogs, underground space utilization, new alloy development, environmental pollutant, migration, geological process modeling, and advanced materials preparation under extreme forces that normal labs can't replicate. The CHIEF 1900, specifically built by Shanghai Electric Nuclear Power Group and shipped to the site on the 22nd of December 2025 for final assembly and commissioning, stands out with its colossal rotating arms, capable of handling payloads up to 32 tons, while generating centrifugal accelerations that combine with mass for the 1,900 G-ton rating, meaning the effective force equivalent to 1,900 times gravity on a 1-ton sample or scaled accordingly, far exceeding the previous world record of 1,200 G-tons from the American facility in Vicksburg, Mississippi, and even topping the facility's own CHIEF 1300 at 1,300 G-tons that briefly held the crown just months earlier. Delving into how these hypergravity centrifuges work in principle and practice to compress space and time, as researchers describe it, the core mechanism spins experimental baskets or cabins on long arms at extremely high rotational speeds, creating outward centrifugal force that simulates gravitational acceleration many hundreds or thousands of times stronger than Earth's 1G, allowing scaled models, for example a 100th-sized dam replica, subjected to 100 G, to experience stresses equivalent to full-scale structures over years of real loading in mere hours of spinning, accelerating processes like soil consolidation, erosion pollutant, leaching through ground layers, or material fatigue that would take decades or centuries naturally, while the G-ton unit cleverly combines acceleration in G with sample mass in tons to quantify total capacity for comparing facilities. The CHIEF 1900's arms are engineered for millimeter precision balance to avoid destructive resonance at speeds generating those immense forces, with vacuum-based temperature control for heat dissipation, advanced vibration isolation in the underground hall, and safety interlocks to protect the structure itself from overpressure or imbalance that could obliterate lesser designs, while experimental cabins host instruments for real-time monitoring of strain deformation, fluid flow, or biological responses under the intensified gravity field that pushes heavier particles outwards, separating multi-phase mixtures or revealing hidden weaknesses in models of bridges, tunnels, submersibles, or space capsules. Capabilities span an extraordinary range of disciplines where geotechnical engineers test slope failures, landslides, or earthquake impacts on scaled infrastructure to improve disaster prevention for real dams, railways, or skyscrapers in days instead of years. Environmental scientists observe centuries of pollutant migration through soil layers accelerated into observable timelines for better remediation strategies. Materials researchers develop high-performance alloys or composites by subjecting samples to extreme stresses, mimicking deep earth conditions. Deep sea and deep land exploration benefits from simulating pressures for equipment design and resource extraction. Biologists study how plants, animals, or cells respond to hypergravity for insights into space travel or extremophiles. And even geological process modeling recreates plate tectonics or volcanic activity in miniature to unlock secrets of Earth's history. All made possible by the facility's 3 centrifuges working in concert with 18 specialized onboard units for tailored experiments across the 6 chambers. As of December 2025, the CHIEF1900 has just arrived at Zhejiang University for installation, following its completion by Shanghai Electric, with commissioning expected soon to activate the full 1,900 G-ton capacity and begin groundbreaking research that builds on the CHIEF1900's early successes, while the overall facility continues expanding toward full operational status, with international attention on how this world-leading tool will advance fields from civil engineering to planetary science. China's CHIEF1900 hypergravity centrifuge is a colossal vanguard of visionary acceleration, blending immense force, precision modeling, and interdisciplinary scope to compress time and reveal hidden truths. What are your thoughts on the CHIEF1900? Thrilled by its 1,900 G-ton record and dam testing potential, skeptical of applications beyond engineering, or curious about comparisons to US facilities? Share your insights in the comments below. Give this video a like if it's spun for you, share it with your science crew, and if you haven't already, hit that subscribe button for more deep dives into the machine's reshaping discovery. Thanks for watching, and I'll see you in the next one.